9 years ago, I worked for the US government in Iraq, helping rebuild the electricity infrastructure. And I was there and I worked in that job because I believe that technology can improve people's lives. One afternoon, I had tea with a storekeeper at the Al Rashid Hotel in Baghdad. And he said to me, "You Americans, you can put a man on the moon, but when I get home tonight, I won't be able to turn on my lights." At the time, the US government had spent more than $2 billion on electricity reconstruction. How do you ensure technology reaches users? How do you put it in their hands so that it is useful? So those are the questions that my colleagues and I at DREV ask ourselves. And DREV is short for Design Revolution. And I took over the organization 4 years ago and really focused it on developing products that actually reach users. And not just any users, but customers who live on less than $4 a day. One of the key areas we've been working on recently is medical devices. And while it may not be obvious that medical devices has something in common with Iraq's electricity grid then, there are some commonalities. Despite the advanced technology, it's not reaching the people who need it most. So I'm going to tell you about one of the projects we've been working on, the Remotion Knee. And it's a prosthetic knee for above-knee amputees. And this project started when the Jaipur Foot Organization, the largest fitter of prosthetic limbs in the world, came to the Bay Area and they said, "We need a better knee." Chances are, if you're living on less than $4 a day and you're an amputee, you've lost your limb in a vehicle accident. Most people think it's landmines, but it's a vehicle accident. You're walking by the side of the road and you're hit by a truck. Or you're trying to jump on a moving train, you're late for work, and your pant leg gets caught. And the reality is that if you don't have much money, like this young man named Kamal right here, the option you really have is a bamboo staff to get around. And how big a problem is this? There's over 3 million amputees every year who need a new or replacement knee. And what are their options? This is a high-end, this is what we would call a smart knee. It's got a microprocessor inside. It can pretty much do anything, but it's $20,000. And to give you a sense of who wears this, veterans, American veterans coming back from Afghanistan or Iraq would be fit with something like this. This is a low-end titanium knee. It's a polycentric knee. And all that means is the mechanism, it's a 4-bar mechanism that mimics a natural human knee. But at $1,400, it's still too expensive for people like Kamal. And lastly here, you see a low-end knee. This is a knee that's been designed specifically for poor people. And while you have affordability, you've lost in functionality. The mechanism here is a single axis. And a single axis is like a door hinge. So you can think about how unstable that would be. And this is the type of mechanism that the Jaipur Foot Organization was using when they were looking for a better knee. And I just wanted to give you a sense of what a leg system looks like, because I'm showing you all these knees, and I imagine it's hard to think how it all fits together. So at the top you have a socket, and this fits over someone's residual limb. And everyone's residual limb is a little bit different. And then you have the knee, and here I've got a single axis on the knee so you can see how it rotates. And then a pylon, and then a foot. And we've been able to develop a knee, a polycentric knee, so that type of knee that acts like a human knee, mimics human gait, for $80 retail. But the key is, you can have this great invention, you can have this great design, but how do you get it to the people who most need it? How do you ensure it gets to them and it improves their lives? So at DREV, we've done some other projects, and we looked at 3 things that we really believe ensures gets technologies to customers, to users, to people who need it. And the first thing is that the product needs to be world-class. It needs to perform on par or better than the best products on the market. Regardless of your income level, you want the most beautiful, the best product that there is. I'm going to show you a video now of a man named Ash. You can see him walking. He's wearing the same knee system here with a single axis knee. And he's doing a 10-meter walk test. And you'll notice that he's struggling with stability as he's walking. And something that's not obvious, that you can't see, is that it's psychologically draining to walk and to be preventing yourself from falling. Now, this is a video of Kamal. You remember Kamal earlier holding the bamboo staff. He's wearing one of the earlier versions of our knee. And he's doing that same 10-meter walk test. And you can see his stability is much better. So world-class isn't just about technical performance, it's also about human performance. And most medical devices we've learned as we've dug in are really designed for Westerners, for wealthier economies. But the reality is our users, our customers, they do different things. They sit cross-legged more. We see that they squat, they kneel in prayer. And we designed our knee to have the greatest range of motion of almost any other knee on the market. So the second thing we learned, and this leads into my second point, which is that we believe that products need to be designed to be user-centric. And at DREV, we go one step further and we say, you need to be user-obsessed. So it's not just the end user that you're thinking about, but everyone who interacts with the product. So for example, the processes who fits the knee, but also the context in which the knee is being fit. What is the local market like? How do all these components get to the clinic? Do they all get there on time? The supply chain, everything that goes into ensuring that this product gets to the end user and it goes into part of the system and is used. So I wanted to show you some of the iterations we did between the first version, the Jaipur knee. So this is it right here. Notice anything about it? It clicks. We had seen that users had actually modified it. So do you see that black strip right there? That's a homemade noise dampener. We also saw that our users had modified it in other ways. You can see there that that particular amputee, he had wrapped bandages around the knee. He had made a cosmesis. And if you look at the knee, it's got those pointy edges, right? So if you're wearing it under pants or a skirt or a sari, it's really obvious that you're wearing a prosthetic limb. And in societies where there's social stigma around being disabled, people are particularly acute about this. So I'm going to show you some of the modifications we did. We did a lot of iterations, not just around this, but some other things. But here we have the version 3, the remotion knee. But if you look in here, you can see a noise dampener. It's quieter. The other thing we did is that we smoothed the profile. We made it thinner. And something that's not obvious is that we designed it for mass production. And this goes into my last point. We really truly believe that if a product is going to reach users at the scale that it's needed, it needs to be market driven. And market driven means that the products are sold. They're not donated. They're not heavily subsidized. A product needs to be designed to offer value to the end user. It also has to be designed to be very affordable. But a product that is valued by a customer is used by a customer, and use is what creates impact. And we believe that as designers, it holds us accountable to our customers. And with centralized manufacturing, you can control the quality control, and you can hit that $80 price point with profit margins built in. And those profit margins are critical, because if you want to scale, if you want to reach all the people in the world who possibly need a knee, it needs to be economically sustainable. So I want to give you a sense of where we're at. We have fit over 5,000 amputees. And one of the big indicators we're looking at, of course, is does it improve lives? Well, the standard is someone still wearing their knee 6 months later? The industry average is about 65%. Ours is 79%. And we're hoping to get that higher. Right now, our knees are worn in 12 countries. This is where we want to get, though, in the next 3 years. We'll double the impact in 2015, and we'll double it each of the following years after that. But then we hit a new challenge, and that's the number of skilled prosthetists who are able to fit knees. So I want to end with a story of Purnima. Purnima was 18 years old when she was in a car accident where she lost her leg. And she traveled 12 hours by train to come to the clinic to be fit with a knee. And while all of the amputees who wear our knees affect us as the designers, she's particularly meaningful to me as an engineer and as a woman, because she was in school. She had just started school to study engineering. And she said, well, now that I can walk again, I can go back and complete my studies. And to me, she represents the next generation of engineers solving problems and ensuring meaningful technologies reach their users. So thank you.